Okay, so yesterday we talked about two different types of triangles. We talked about equilateral triangles and we talked about isosceles triangles, right? So there's two different types. Do you remember what isosceles triangles have or what they look like? Isosceles. What do you remember about? Two matching sides and two matching angles. What about equilateral? What do those have? All sides are the same and all angles are the same. Good. So in our two pictures here, we've got two different triangles, and I want to know just the measure of the angles on the inside of the triangles. So if you look at your very first one there, triangle KLJ, what type of triangle is this one? Is it isosceles or is this one equilateral? Whoa, I heard both. What are you given in the picture? Two tick marks only. Are you given three tick marks? No, you're only given that two sides are the same. So since only two sides are the same, it is isosceles. Sides having a tick. All right. The sides are the same and two of the angles are the same. Which two angles are the same? J and L, very good. So if you go across from the tick marks, you will find your two base angles that should be exactly the same. So angle L and angle J should be exactly the same. What would be angle J then? 68 degrees. Good. So this one has to be exactly the same. All right, so you've already figured out one of your angles. So you have two angles that are the same, one angle that's different. So your angle K is the one that is different. How am I going to figure out angle K? Perfect. I'm going to add angle L and angle J. I'm going to add 68 plus 68, and then I'm going to subtract it from 180 because every triangle is always 180 degrees. So I'm going to do 180 minus 68 plus 68. So I'm adding 68 and 68 together, and then I just subtract it from 180. What do you get when you do that? 44 what? Degrees. Very nice. So you're left over with 44. That means this angle up here is 44 degrees. Very nice. So every triangle, no matter what type, has to have all of the angles add up to 180. All right. Letter B. What type of triangle is this one? Is this isosceles or equilateral? Why? There's only two tick marks, there's only two sides and two angles that are the same. So this one is also isosceles. Okay. Now that means two of the angles have to be the same because two of the sides are the same. Which two angles are the same? C and what? C and E. Okay, good. This angle and this angle are exactly the same. But I got a little bit of a problem, right? Because I only know angle D. Angle D is 106 degrees. How am I going to figure out what the other two angles are?
You're going to minus 106 and divide that by 2.
Oh my gosh, fantastic. Why am I dividing it by 2?
So then you get one angle.
Good. There's two angles. They're both exactly the same. So to get what each of those angles is, I'm going to divide it by 2. Good. So I'm going to take 180 and subtract 106. What do you get when you do that? Just 74. Right? So 74 means angle C and angle E, when you add them together, should be 74. So if I take that and I take half of 74, what do you get? 37 what? Degrees. Good. So angle C is 37 and angle E is 37. And so I can check just to make sure. If I add 37 plus 37 plus 106, what should I get? 180 when I add them all together. Very nice. Okay. questions, comments, concerns? How do you feel about it? Feel okay? Show me a thumbs up, thumbs down. How do you feel? Or thumbs to the side. I don't care. Okay. Cool. Cool, 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 cool. Fantastic. All right. Today, we're going to talk a little bit more about isosceles triangles. So we're going to talk a little bit more about their properties, what they look like. You're going to love isosceles triangles today. So you're going to notice something very fantastic, very easy about them. So that's great. All right. So from the back, you should have grabbed a paper, put your name on it. Make sure you are looking at the side that has the picture of the house on it, please. Not the other side, because the back side is going to be your homework. Dun, dun, dun. But the front side we're going to do today, right now. I'm hoping we can get through pretty quickly so you have enough time to do a little bit of your homework during class. All right, so today, like I said, we are just talking about isosceles triangles and nothing else. Only isosceles triangles. So we're only going to be talking about triangles that have two sides that are exactly the same and two angles that are exactly the same. So today, as we go through, we're going to talk about isosceles triangles that are bisected. What does the word bisect mean? Yeah, cut into two or cut in half. Very good. So we're going to talk about bisecting or cutting in half some isosceles triangles. Now here's the cool part about cutting an isosceles triangle in half or bisecting it. If you have one big isosceles triangle, and so in this first picture here, it's triangle A, B, C, this whole really big triangle. If I bisect it or cut it in half, what I end up doing is creating two smaller triangles that are exactly the same. So if I've got one big triangle that I cut in half, I now have these two smaller triangles on the left and on the right. The side segments here are exactly the same. The angles at the bottom, so like angle C and angle A, are exactly the same. And this angle B over here on both sides, I should really put two here. This angle B on both sides is also exactly the same. Additionally, these bottom pieces are also going to be the same. So literally, when you have an isosceles triangle that is bisected or cut in half, you've got your really big triangle, and when I cut it in half, it's two small triangles that have just been reflected. Everybody see that? So if I took this triangle and I flipped it over to this side, everything's exactly the same. These angles are the same when they flip over. It's like a mirror. These two angles are the same. These two sides are the same. These two sides are the same. This side is the same. So it's just it's one big triangle that's been cut in half to two small triangles that are exactly the same when I flip them over. Okay? And so everything about it is the same. The only other important thing is when you bisect and you cut in half, you create 90-degree angles. So you're going to be creating some right triangles as you go through. All right. So we're going to go through. We're going to mark everything in our pictures that looks exactly the same. And then we're going to solve for some unknown sides and some unknown angles. So in this first problem, number one, you've got your really large triangle. That's your isosceles triangle. Okay, the big one there. And I cut it in half. I bisect it. Right? So that's what this piece is right here. I'm bisecting it. When you cut it in half, you create 90 degrees on both sides. 90-degree angles on both sides. And now you've got two smaller triangles that are exactly the same. So here's one triangle over here on the right, And then here's another triangle on the left. And so everything about these two triangles is the same. They've just been reflected or flipped. So if you look at this first triangle over here in pink, you see that one of the angles is 31 degrees right here. Okay, which other angle also has to then be 31 degrees? R. Good. So let's mark that in the picture. Oh my God. This thing is calling. All right. So guys, 31 degrees, 31 degrees. 90 degrees, 90 degrees. All right. You also see this angle up here, angle S on the right. I don't know it, but what angle should it match with? The other S on the other side, right? These two angles should be exactly the same, right? It's just flipped. Okay, so the first question is, what is the measure of angle RSQ? RSQ. So I want to know what's just this little piece in here. So I'm going to ignore the triangle on the left. I'm just going to look at the triangle on the right. How would I figure out what that one angle is? What would I have to do? Perfect. Exactly what we're going to do. We're going to take 180 and we're going to subtract 90 and 31. Right, so I just add those two numbers together and then I'm going to subtract them from 180. So 90 and 31 gives me 121, and if I subtract that from 180, I get 59 degrees. So this little piece right here is 59 degrees. Well, where else is it 59 degrees? On the other side right next to it. This side's also 59 degrees. Right, so if you figure out one triangle, you've got everything you need for the other triangle. It's just being reflected or flipped over. Okay, next question is, what is PR? Now, PR is a side length this time. It's not an angle. So if I start at P and go all the way to R, that's this whole entire length. Now, you already know part of it. What part do you know? You know the 4. So this piece from Q to R is 4. That means the other side has to be 4 as well, right? It's just being flipped. So if I wanted to know the entire distance, what would I have to do? Just add them together. I'm going to add 4 and 4. So what is my distance for PR? 8. That's it. And you're done. So I truly love isosceles triangles because once you figure out one, you have the other one done already, right? You only have to figure out one triangle and then it's just reflected over. Everything's the same. Okay, so that's the cool part about isosceles triangles. All right, questions there? Not too bad, right? Pretty easy? Okay, no one's answering. Cool. Cool, friends, sorry. Okay, number 2. I'm going to do the same thing. I've got my big triangle here, and I'm going to highlight, here's one triangle on top, and then another triangle at the bottom. Oh my goodness. All right, so I've got my triangle on top, got my triangle on the bottom. We're going to mark everything that is the same in both of them. Okay, you already one angle that you know. What angle do you know? Angle B over here is 67. Okay, which other angle also has to be 67? C, so let's mark it. Okay, you know another angle. What other angle do you know? 90. Where else should there be a 90? On the other side right next to it. Okay, good. We'll just start there with the angles. We'll do the sides in a second. Okay, first question says, what is the measure of angle DAC? DAC. So I want to know, what is this little piece over here in pink? So I'm going to ignore the blue triangle. I'm just going to look at the pink triangle. How am I going to figure out that one angle? Exactly. Noticing a pattern here. We're doing the same thing over and over. I'm going to add the 90 and the 67, and I'm going to subtract it from 180. Right, so I added this one plus this one, and then I'm subtracting it from 180. So if I add 90 and 67, I get 57, and then I subtract from 180, and I get 23? Yeah. 23 degrees. So this piece right here is 23 degrees. What does that mean the piece right next to it is? 23 degrees. Okay, see? Isosceles are not hard. Once you figure out one, you figured out the other. Okay, now, letter B says, what is BC? So BC is now a side length. BC, here's BC. It's the whole thing. How am I going to figure that out? Ah, very nice. So this is already a 10 over here. That means automatically the other side is also 10. So to get the whole thing, I just add 10 and 10. So BC is 20. Good. Easy stuff, right? All right, last one. What is AC? Okay, now I got a problem. I want to know, what is this side length over here? Nope, so 24 is this length right here. That's AD, yeah. Okay, so here's what I'm going to do. I'm going to make this a little easier for myself. I'm just going to redraw this triangle right here, my smaller triangle at the bottom. I'm going to redraw it. Okay, it's triangle ADC. All right, so I'm going to ignore the top blue one. I'm just going to look at the bottom one. I already know this side AD is 24. And I know this side DC is 10. I want to figure out this side AC over here. Now, this is a right triangle because there's a right angle in it. You know a theorem. I have not taught it to you, but I know you know it. It's a theorem that helps you get the side lengths of a right triangle. Who remembers what that theorem is? The Pythagorean Theorem. Do we remember doing a squared plus b squared equals c squared? Do you remember that from like 8th grade? Yeah. I hope so. It's my favorite theorem, so you're gonna remember it. We're gonna use that theorem to help me solve an unknown side. So you can use this theorem when you have a right triangle and you know 2 of the 3 sides and you want to find the third side. So we're going to do a squared plus b squared equals c squared. The a and the b are the legs. The c is the hypotenuse. It's the one across from the 90. That's the only one that really matters. You can put the a and the b in either spot, but you have to put the c as the one that is across from the 90. So if you look at this picture, which one is across from the 90? You know that side? No, so that's the side I'm going to solve for. I'm going to leave it as c squared. My other 2 numbers are my a squared and my b squared, but it doesn't matter which order you put those 2 in. So I'm going to do, you can either do 24 squared plus 10 squared, or you can put 10 squared plus 24 squared. Doesn't matter, you're going to get the same thing. I'm going to do 10 squared plus 24 squared. All right. Now the first thing I'm going to do is my exponents. 10 squared means 10 times 10. 100. Plus 24 squared means 24 times 24. 576. Awesome. Equals c squared. Now it's an algebra problem. What should I do next? Good. Just add the two numbers together. So I get 676 equals c squared. And I've got one last step to get the c all by itself. How do you get rid of squaring something? Square rooting. Nice. So do you guys remember doing this square root when we did the distance formula at the beginning of the year? Remember that? Maybe? No? So if you go to put this into your calculator on your phone, you're going to put the number 676 first, and then you have to turn it sideways. Do you remember doing this? And then the square root is the one with the little 2 right next to it. So my square root is 26. So this side length over here is 26. That means this side AC is 26. Well, if AC is 26, what else is 26? AB on the other side. Good. Okay, so if you can figure out one triangle, you can figure out the whole thing. All right. That's probably the hardest one. So if you can make it through that one, we're golden. All right, can I move it? Number 3? Does anybody still need it? All right, number 3. Again, I've got an isosceles triangle. I have 2 different triangles. I've got one on the left, and then I've got one on the right. So we're going to start just by marking everything that's exactly the same. Okay, what's one thing that is the same on both sides of that triangle? What's one thing you see? 90 degrees. Good. You should have a 90 on both sides. Fantastic. Put that in. All right, angle G is 4x plus 9 degrees. Which one should be the exact same as angle G? Flip it over. Angle B. So if angle G is 4x plus 9, what does that mean angle B is? 4x plus 9 degrees. Okay. I see this side of angle K on the left is 3x plus 4. What else should be that? The other side right next to it. So this piece over here should also be 3x plus 4 degrees. All right, so it's the same thing. It's just flipped. It's a reflection. All right, now we're going to solve for x. We're going to look at just one of the triangles, either the left one or the right one. It doesn't matter which one we choose because they're exactly the same. So let's just look at this pink triangle over here. All right. I know all 3 angles of this triangle, don't I? What do I have to do to solve for x? What? Very nice. I'm going to take all 3 of these numbers, add them together, and set them equal to 180. So I'm going to take 3x plus 4 plus 4x plus 9 plus, don't forget, your 90. And then I'm going to set that equal to 180. And then it becomes an algebra problem. Do you think you can finish that problem? Combine some like terms. Please. Combine some like terms. Let's see if we get the same answer. Mm-hmm. Froze it, right? Okay, good. Whew. Good. So combine all your x's. Good. Get all your numbers together. And if you're feeling really confident, you can even try the next one because I'm not going to do number 4 with you anyway. So I'm going to try that one once you're done. Okay, now move your to the other side. Yoo-hoo! Don't forget your degree symbol because you're talking about an angle. Whoa. Careful. That divided by that is not that. Nothing. What are you doing? Nothing. All right, check your work, Miss Massos. Did you get 11 degrees? Almost everybody did, so fantastic. I love to see that you guys are already started on that second one. Fabulous. So I'm going to, even if you're already started on that one, I'm just going to go jump down to 5 because that's the last one I want to do, and then I'll let you finish that other problem up, okay? But I want to make sure you have enough time to finish number 5. And then the rest of the problems on the back are going to be homework. They are quick though, but there's 11 questions on the back. All right, last one, number 5. Can I have somebody read number 5 for me nice and loud so we can all hear them? Who'd like to read? Jaden, thanks for making eye contact. Go for it. If you could read that for me nice and loud, I'd appreciate it.
Prefabricated house delivered to the foundation two symmetric paths that are assembled on site. Along the plane route to the site, the truck must pass under a bridge and has a clearance height of 17 feet. Should the trucker plane a different route for delivering the house? Explain.
Okay, so this is real life stuff. If you have ever seen people like go with like their tiny homes on the back of their trucks or whatever, right? This is thing because if you have a house that is taller than 17 feet and the clearance is only 17 feet, well, what's going to happen when you try to drive under it? And your house is bigger than that. You're going to get yourself into an accident, obviously, because it's not going to go under the bridge if it's bigger than 17 feet. So we want to check and see if this house is taller than 17 feet. So we want it to be either 17 or less than 17 in order to go on that route for this particular house. So if you take a look here at this picture, I want the height of my house to be either 17 or less feet. Now, you already know part of the triangle or part of the house right here on the right is 10 feet tall. Okay, so that means you have to figure out this height right over here. In order to fit underneath the clearance, this cannot be bigger than what? What's the biggest number I'm allowed to have there? 7. If it's bigger than 7, your house isn't going to fit. So if this height right here is bigger than 7, this orange piece, then I can't take that route. All right, so you already know this 10 here. So up here at the top, I have an isosceles triangle. And so I've got my big triangle here. And then now I've got my two smaller ones on the inside. You already know this side piece over here is 16. I need to figure out what these two sides are. Now, you are not given this height right here. You're not given this piece over here at the bottom either. You are given, though, this 28 feet at the bottom. That's this whole thing. So 28 feet is the entire length across. So that means this whole segment is 28. What if I just wanted one piece of it, though? How would I figure that out? Yeah, divide it by 2. I'm going to bisect it. I'm going to cut it in half. So I'm going to take that 28 and divide it by 2. Well, what is 28 divided by 2? 14. So this piece of the triangle is 14. This piece of the triangle is 14. If you are bisecting it, what kind of angles are you creating? 90 degrees. So I'm going to draw my 90-degree angles. Now you've got yourself a right triangle. So I'm going to redraw just one of the triangles, make it a little simpler for me. Just redrawing it a little bigger. Here's my 90. The 14's at the bottom. The 16's on the side. And I'm trying to figure out what's this height over here. Okay. So I've got my right triangle, and the theorem we use when you've got a right triangle and you know two of the sides was the Pythagorean Theorem. So we're going to use it again. Let me do it over here. A squared plus B squared equals C squared. Now remember, the C is the one across from the 90. What is your C value this time? 16. So I'm going to put a 16 in for my C value. It does not matter what you put for the other two then. So one of the other numbers I'm given is 14. So that's my A value. And then the one I'm going to try to figure out will be the B value. So I'll just leave it as B squared. All right, now we're going to go through, we're just going to solve it. So the first thing I'm going to do is all of my exponents. 14 squared means 14 times 14. Does anybody know what that is? Nope, that's definitely not. 196. So it's not times 2, it's times itself. Plus B squared. And then 16 squared means 16 times 16. I don't know what that is. 256. All right, this is an algebra problem. What do I do next? Oh, take one. First, I'm going to subtract the 196 before I square root. I get B squared equals 60. And now, what's my last step? Square root. Okay, so when I put this in my calculator, I put the 60 in first, and then I push the square root button with the little 2 right next to it. So the square root of 60 is 7.7. Okay, so this piece right here is 7.7, this height. My other height is 10 feet. What is my total height? 17.7, right? It's the 10 plus the 7.7. It's 17.7 feet. So, should this person take the planned route? Are they going to pass under the bridge? No, they are not going to make it across the bridge, so they have to find a different route. So I am too high by 0.7 feet. Too high. So they should take a different route. All right. So you've got one question left on the front, number 4. And then you have the back side of this worksheet is your homework. Questions on the back. The first few are all like the warm-up. Okay, all of these are like the warm-up. Huh? Yeah, this one right here, if you didn't finish this, number 4. This one's homework. If you already did it, then fantastic. You don't have to do that one. But if you didn't, you've got to do that one. And you've got the back side to do as well as your homework tonight. Yep. So I don't think it'll take you that long. I know that there's 11 questions, but they're all algebra types of questions. And the first, like, 6, you should be done very, very quickly on the back side. Okay? So the numbers 1 through 10 look like what we did for the warm-up and what we did yesterday. And then number 11 looks like the front side. Okay? So your homework is to complete that. You're going to take a picture of it when you're done, and you're going to submit it online when you are finished into Canvas. You've got about 5 minutes right now. I think you can at least get through a couple questions, okay? But when you are done, you're taking a picture. That is your homework for tonight.